Welcome to Pinterest. I'm really excited to welcome you all to Pinterest's second annual Machine Learning Day. I'm Jure Leskovec, Chief Scientist at Pinterest and also Professor of Computer Science at Stanford. At Pinterest, I work on machine learning systems, recommendations, and user modeling. At Pinterest, we have pioneered graph neural networks to great success and scaled them up to the entire Pinterest ecosystem. The goal of this event is to bring together machine learning leaders, engineers, and scientists and highlight cutting-edge machine learning research and technologies developed and deployed at Pinterest for the benefit of its users. Pinterest is a very unique platform because at Pinterest we have users that come to search and discover their taste and then execute on that taste to perform an action. We observe the user through the entire intent creation phase, from casually exploring and browsing, saving different ideas, and then honing down, narrowing their interest, deciding what they want to do, and then either performing that action in the real world or purchase something on the web. So shopping, user modeling are very important to us. The second important aspect that we are really excited about in terms of machine learning is understanding content created by our users, and especially content in the form of video, because that can serve as a way for users to be able to make their decisions faster and quicker discover what are the things, what are the products, what are activities our users love. For today, we have an exciting agenda. We will start with the keynote speech by Deepak Agrawal about the vision of machine learning at Pinterest. We will then continue with a senior leadership panel discussion and then have a series of lightning talks highlighting particular impactful and interesting machine learning projects and challenges at Pinterest. We are going to conclude the day with a technical panel discussion. Senior leadership panel discussion will focus on business and technical opportunities for machine learning at Pinterest. The technical panel will discuss interesting machine learning problems in the Pinterest ecosystem, especially as we are thinking about content creators and communities of users inspired by the content created by these influencers or creators. So, I'm really excited to welcome you all at Pinterest Machine Learning Day. Thank you for coming, and I hope you'll have a great day and that you are going to enjoy the event. So now I would like to introduce our keynote speaker. Deepak Agrawal is a senior engineering leader at Pinterest, where he leads engineering teams responsible for developing all organic user experiences on the Pinterest platform. This means all the recommendations, all the ranking, entire search, as well as the entire shopping part of Pinterest. Prior to Pinterest, Deepak was a VP of engineering and head of artificial intelligence at LinkedIn for over 8 years. Deepak began his industrial research career at legendary AT&T Labs and then joined as a senior researcher at Yahoo Research, where he has done very impactful work on monetization, computational advertising, recommender systems, and so on. Deepak has published extensively in top-tier conferences in machine learning, computer science, as well as statistics. He has also written a recommender systems book. Deepak is a fellow of American Statistical Association and serves as on the executive committee of ACM-SIG KDD, and also is going to be the program chair of the next web conference. So with that, I'm handing it off to Deepak.
Thank you, Jure, for the kind introduction. Hello, everybody. Hope everyone is doing great. Very delighted to be here. This is my first ML day. I joined Pinterest last year, and I'm very delighted to be here today to share our journey of how we use machine learning to power inspiration to action journey for all our users who we refer to as pinners. So you're going to see me use the word pinners throughout the talk to refer to our users. So first, a little bit about Pinterest. As you may all know, Pinterest is the most popular lifestyle app in the world. Our mission is to bring everyone inspiration to help them create the life they love. And we are available worldwide. We have more than 500 million pinners visiting us on a monthly basis, looking for things and inspiration like home decor, food and drinks, fashion and beauty, education, arts, and many other things like that. So at a high level, Pinterest is really a visual discovery engine that helps our pinners get inspired, plan, and get things done. And as you will see later on in the talk, ML plays a very foundational role in building the discovery and search experiences that power all our products. So the first and foremost thing I want to talk about that is powering the product is what we call the taste graph. So our community of create pinners have really helped us build the taste graph by curating billions and billions of content pins across the internet. So let me tell you what the taste graph looks like and what the curation process looks like. So this is me visiting the home feed, and I browse through the home feed. I like a pin that I really enjoy, and I'm actually in the midst of revamping our garden. So this is a pin and idea I like. I go and look at the pin, and then I like it, and I save it to the board. The system automatically recommends me a board, and got the board spot on, my home decor, my home garden, and I go and save the pin there. So this is what we call the curation process. It is a pinner saving an idea and putting it and pinning it to the board, right? And this taste graph, along with all the rich pinner interaction data, when combined with the powerful machine learning technology, is what powers Pinterest and produces the magical experiences that pinner come to the platform every single day for. So as evident by now, as I told you, like, we are a machine learning first product. Machine learning is not a nice to have for us. It is at the heart of everything we have built into our product. For instance, we use machine learning to understand the heterogeneous content that we ingest for multiple sources, right? So we ingest content from the web, we ingest content from videos that are created by creators who are on our platform, we ingest product pins that are created by merchants, and of course we ingest content that is produced by our advertiser. So this content understanding then helps us create filters that helps us remove unsafe and spammy content from our site. It also helps us remove low quality content from our site. It helps us extract knowledge about the content, which helps us build the knowledge graph that powers a lot of user experiences on our site. We also use the same content understanding technology using computer vision and NLP to create embeddings, which are very popular nowadays. We also track the performance of these content as it plays in our system. We also use the same technology for content to understand our users. What are the tastes of our users? What are their interests? What is their intent? And once we are armed with this understanding of content and users, we use it to recommend content to our users, which is all about distributing the right content to the right user at the right time in the right context. And in order to do that, we use state-of-the-art machine learning methodology like explore, exploit, deep learning models to predict utilities, multi-objective optimization, and so on and so forth. So next, in order to just give you the flavor of machine learning technology at Pinterest at a high level, I'll talk about some of the foundational elements that we have in our machine learning stack. You will hear details about some of those later on in the day as well. And again, this is not an exhaustive list of things, but it is just meant to give you a flavor of what our machine learning technology looks like at Pinterest. So first and foremost, I want to begin with my favorite topic, which is about productivity and efficiency of machine learning at Pinterest. So as I told you, we are a machine learning first company, and hence we deeply care about building an engineering ecosystem and process that helps our bright and talented machine learning engineers to easily unleash the creativity and help us improve the product experiences for our pinners every single day. So the first thing is we ensure that once things are in production, it runs almost automatically and does not require babysitting from a machine learning engineer. I mean, we all have been there. It is not a fun thing to be babysitting something that you've already rolled out in production. And that is something that we take very seriously. Next, we have made sure that it is very easy for anyone with an idea, either testing a new feature or new signal or trying out something else very easily with high experimentation velocity in in production, right? And so productivity, makes an engineer more motivated and also improve the quality of ideas they actually come up over time. Obviously it has a significant impact on business as well. And in order to just see this, I like to use this equation. So again, very simple, very self-explanatory, but still I want to put it out there. So the total amount of impact that machine learning has on a particular metric, let's say sessions, is equal to the number of engineers, of course, working on the problem times the number of experiments that is rolled out by every single machine learning engineer. So you can think of the first part of the equation as developer productivity. But again, rolling out experiment is not enough. The experiment should have a high probability of success. And even that is not enough because you can roll out a lot of successful experiment with very little impact. So it also depends on the impact each experiment has. And so if you combine these two things, the quality of ideas and developer productivity, that is what gives you the total impact that you have in the system. I also want to point out that developer productivity and the quality of ideas are not uncorrelated at all. Like if you have engineers working in a great environment where they can really test things very quickly, they get more motivated, and the quality of work that they do over time also improves, right? So developer productivity is really key in terms of rolling out huge impact through machine learning on our ecosystem. So the next question, again, how do we ensure that developer productivity is great at Pinterest? So roughly speaking, you can think of our machine learning development process as three different components. One is feature development, all the features that you use in models and you want to test. Then model development, and then finally productionization. And for each of these three components, we have some shared component that can be easily leveraged by everyone across the entire organization. For instance, in the feature marketplace, we have a feature marketplace where if you are developing a new machine learning application, you can actually piggyback and kind of use some of the features that are already available. If you go to model marketplace, there are model components, shared model components that you can easily use and embed into your application. We have service libraries that will help you productionize the machine learning model that you have created and help you experiment with them very quickly in production. Similarly, we have also built multiple platforms like the Signals platform, which supports batch processing, streaming processing. We have built a machine learning training platform that has all the components that helps you do distributed computing at scale. We also have built machine learning serving platform. These platforms are really help our machine learning engineers to kind of roll out a new machine learning application at ease by leveraging all the machine learning platform that we have. And as I was mentioning earlier, once we roll out things in production, we have a unified health monitoring system that makes sure that everything that's running in production is running in a very reliable way, so that we don't have any production outages and things like that. Okay, so in order to ensure that we can scale our infra efficiently, reliably, and without compromising latency, while supporting all the sophisticated machine learning computations, we have built a very scalable system architecture as well. For instance, we have elaborate logging of user interactions that happens on our site, strictly adhering to privacy constraints. That is front and center in terms of what we do. We ingest content from various sources. We have built both batch and streaming systems to process and understand content at scale. We have built sophisticated multi-stage ranking services consisting of state-of-the-art candidate generators and ranking models. And these combined can actually select a few personalized recommendations from billions of things to choose from in a matter of seconds at runtime. So this is extremely important for us as we roll out new solutions, machine learning solutions in production. As I was saying, so now zooming into some of the components of our infrastructure, like content signal, as I was saying, is extremely important for us to keep our site safe, to keep our site free from spam and other things, and make sure that quality is very high. We have built a system. The general high-level flow is very simple. You figure out what you want to predict and understand from the content. You collect labels, you do classification, and then we use an active learning framework where we continuously prioritize and label cases where we have low confidence. And as we collect that data, we continue to retrain our models and roll it out in production. We have built a knowledge graph that consists of nodes that represent various kinds of interests, like food and drink is a node here, and then food and drink, for instance, it's Thanksgiving is coming, so it's a very good occasion for food and drink, and people then try out recipes like roasted turkey, and then there are different ingredients that you need to cook roasted turkey, then cooking time. All of these nodes are encapsulated into our knowledge graph, which is then used by us to recommend and to search significantly better results than we would otherwise in our systems. We also use non-parametric deep learning methods to do visual embedding models for images. I'm not going to go through this. You're going to hear more about this later on in the talk, but roughly we use CNN and Transformer everywhere. That they seem to be very popular, and they seem to work very well in production as well. This is an important one I want to call out. So the taste graph that I talked about, the pinner to board graph, is something that we use very effectively to create a better understanding of content by actually using the pin to board graph using graph neural networks. So essentially the idea here is for every single node, in order to get better feature representation for content, you do spatial smoothing by looking at the pin to board graph using graph neural network technology, coupled with all the transformer work that has recently become very important in the deep learning literature. And then obviously, as we understand content, we look at the user's behavior, past behavior, look at the sequence of behaviors, and use all the understanding that we have obtained about that content to get better understand users' intent and interest. And that obviously helps us do a much better job of recommending the right content to the right user at the right time in the right context. And this is, again, based on transformer as well, which, again, you're going to hear later on in the day more about. And finally, once these horizontal capabilities are available, every single application builds deep learning models to predict various actions, various utilities like click rates, save rate, time spent on the site, and so on and so forth, advertising, click rate, conversion probability. All of these things are application specific, but they use a similar kind of deep learning structure. And I think we are one of the few companies that have rolled out such large-scale deep learning prediction models at scale in production for the kind of traffic that we have on site. There are other companies who have done that as well, but we are one of the few, I believe, who have done that at scale. I also want to talk about inclusivity and fairness. So this is the first principle that we use when we are developing ML solution. This is not an afterthought for us. For instance, we have heard loud and clear from our pinners that they want to feel represented in the product. And in order to kind of make our machine learning more inclusive and fair, we have built things like skin tone ranges. We have built skin tone ranges so that the search is more inclusive. It provides pinners an option to filter beauty results by skin tones. Recently, we also launched a similar feature for hairstyle, for instance, and we are working to roll out several such features in the future as well. All right, so this was an overview of some of our foundational stack. I want to now spend the next 5 minutes talking about the next big challenge that lies ahead of us. So as you can see, we are really strong in terms of providing inspiration. We have also helped pinners to act and do things, but we believe we have a lot more to do to make the inspiration to action journey more seamless, more delightful, and more efficient for our pinners. We believe there is a lot more opportunity for us in this space. And we will do that by connecting pinners with the content, with the creators who create that content, and with other pinners on the platform in the future. And we believe in order to do that, machine learning has to play a very pivotal role in our journey ahead. So for instance, we are transforming the experiences on our site by connecting pinners. So far, Pinterest was about connecting pinners to content. Now we have introduced a third element into it. It is about connecting pinners to people who create those inspiring content. And these inspiring creators, they create content that is authentic and uplifting, content that is really made for you, content that sparks action, content that is timely and enduring, and content that is engaging, visually engaging as well. So this is a very big shift for us in terms of product. It introduces another vector in our tensor space when we are doing recommendations in search, and it's an extremely important component for us moving forward. Then shopping. I mean, as we all know, shopping is not a one-step process, it's a journey. And we want to build experiences, shopping experiences that are more taste-based. It is a multi-step process. It starts from a broad idea, then you get inspired, then we have to learn about your preferences, we have to help you refine your choices in the search surfaces, and finally it leads to seamless purchase for you, right? That's exactly what the shopping journey should look like. And as you can imagine, it's a very complicated machine learning problem. So we are really heads down building this stack, building this experience for our pinners, right? And some very, again, you'll hear more about this later on, some unique challenges. Shopping has its own unique challenges, like creating high quality catalog, providing inspiring shopping recommendations, visual shopping that inspires you to kind of and helps you do more delightful shopping. All of these are components that are really important for us to get right at the foundational level to build that magical shopping experience that I was talking about. Right. So as we are embarking on this journey, I wanted to just call out and leave you with these things, like some significant ML challenges that we are going to be solving in the next few years. I hope you can be part of that journey. One is, of course, we understand our users pretty well today, as I was talking about earlier, but there is a bigger need to even more deeply understand the pinner interest and intent for all their lifestyle choices. And again, another big thing is we have to be adaptive in our understanding for users. Like some events that happen in your life are more predictable, like things that you do by season, that is more predictable. So we should know that. Of course, it's seasonal, but we should still be able to predict that. But some of them are more sporadic and unpredictable. Like suddenly if you started to plan for a wedding, or you wanted to have or you had a baby or something like that. I mean, these are things, of course, that are not repeatable in the data, but they're extremely important. And our ML algorithm needs to be able to detect these change points and adapt and change the recommendations accordingly so that users have that wow experience when they come to the platform. And obviously, this is a hard problem, but we are really excited about working on this problem. Inspiration to action journey, as you saw, is not a single step process. It is a multi-step process. I mean, so optimal point recommendations cannot solve this problem in an optimal way. We need to optimize the entire inspiration to action journey, not just one particular recommendation. So more work is needed in this area, I believe, to really come up with new and better recommendation methodology in the future. And finally, as you can imagine, at the foundational level, we need a lot more work to better understand our videos, create way better catalog, and also enhance our knowledge graph as much as possible for all lifestyle verticals. So with that, I'll thank you all for listening. Really appreciate all your time.